Today we're going to talk about expressions. First, we have to start with a variable. A variable is a quantity that may change within the context of a mathematical problem or experiment. Typically, we use a single letter to represent a variable, although some letters are saved for not variable use. I'll talk about those in a second. In an expression, a variable represents any number, and in an equality, a variable represents specific values. In an inequality, a variable represents a specific range of values. This should say inequality here. So typically you'll see x. We use x, y, and z quite a lot for variables. Pi is not a variable, it's an actual number. So is the letter E. This is Euler's number. It's about 2.71. And we don't use E as a variable. X, Y, and Z are normally the ones we use. We also use A, B, and C quite a bit. An algebraic term can be a signed number, a variable, or a constant by a variable or variables. Each term in an algebraic expression is separated by a plus or minus sign. So an algebraic term could be like the number 7. That's an algebraic term. 2x is an algebraic term. Negative 4x squared y cubed is also an algebraic term. To be an algebraic expression, we would just put addition or subtraction signs in between all of these. Something you're going to talk about in class. Why do you think it says signed numbers and not integers? Think about what is in integers that probably is not in signed numbers. The properties of terms. The coefficient is the number that is used to multiply a variable. So 2x cubed, 2 is the coefficient. The degree of the term is the sum of the exponents of each of the variables of a specific term. So we had 7 before. We had 2x before. And we had negative 4x squared y cubed. The degree of this term is the sum of the exponents of the variables. There's no variables, so this is degree 0. The sum of the exponents of this variable has an exponent of 1, so this one is degree 1. This term, the negative 4x squared y cubed, the exponents are 2 and 3, so the degree is 2 plus 3, which is 5. So the degree of this term is 5. We just said an algebraic expression is an expression that consists of integer constants, variables, and their algebraic operations. An expression is a group of algebraic terms that are separated by plus or minus signs. In expressions, a variable can take on any value unless there is a restriction placed on the values. Some usual restrictions are preventing the denominator of the expression from taking on the value of 0 or making the value of an even root positive. So an algebraic expression, most of the ones we're used to seeing are, say, x squared plus 3x minus 4. We're normally used to seeing quadratic algebraic expressions. You could even have 5x cubed out here. But algebraic expressions can be any terms together. So 3a squared b to the fourth minus 2z. That's an algebraic expression. And then the last thing we talked about was restricting the values. So sometimes you'll see something like 5 over x, and then you'll have a comma, and x will be greater than 0. Or x will not equal 0. So that's making sure that denominator doesn't equal 0. There's other times you'll see this, but that's what that means. It's just so that we don't have problems with denominators, or we don't have problems when we're taking roots, which we'll talk about in a couple sections. A constant of an expression is only contains an integer. So a constant expression are just integers. So like 7, -4, 63, those are all constant expressions. An expression consisting of only one term is a monomial. So 3x 4x to the fifth, those are all monomials. An expression consisting of two terms is a binomial. So x plus 3 4x squared minus 2, those are all binomials. Trinomials have three terms. That should say 3, not several. So again, we're used to seeing quadratics, x squared minus 4x plus 3. And a polynomial has several terms. Typically, it's more than 3 because we call trinomials the ones with 3 terms. Definitely more than 2. A rational expression is an expression consisting of a rational term. So a rational term is going to be anything with a rational number, anything that's a fraction. So 4 over x squared, that's a rational term. So any expression that would have something like that is a rational expression, including if we had 1/2 plus 3x. This is technically a rational expression, but usually we consider this constant term. Usually we consider rational expressions having variables in the denominator. It's not always the case, but that's normally how we think about it. Then a radical expression is an expression consisting of a term with a radical. So the radical sign is the square root sign. And then also any other roots. So a radical expression could be square root of x. A radical expression could also be the square root of 17 and then plus x to the third after that. Again, typically we think of radical expressions as having a variable in the radical. The other ones to consider are higher roots. So these are square roots because there's nothing here. Again, in a couple sections we'll talk about higher roots. So the cubed root of y, that's also a radical expression. As long as it has this root sign, then it's a radical expression. The degree of the expression is the degree of the highest term in that expression. So we have to find the degree of the highest term, or we have to find the degree of all the terms and then figure out which one's highest. We're going to have an example in just a minute. The leading coefficient is the coefficient that is associated with the highest degree term. So a coefficient is what is multiplied to each of the variables. The leading coefficient is the one with the highest degree term. Descending order. Typically when we talk about polynomials, we start with the highest degree term and then step down from there. Again, we'll have an example in just a second. And then the constant term is the term that doesn't have any variables. Our example is coming up in just a second. But we want to talk about polynomials first. Polynomials with one variable, so only x, only y, only a, are classified by their degree. I've just listed the most common ones because those are the ones that have names. So if the degree is 0, it doesn't have a variable, it's a constant polynomial. If the degree is 1, so it has just an x term, then it's a linear polynomial. If the degree is 2, so here we have a degree 2 term, a degree 1 term, and a degree 0 term, so the degree of this polynomial is 2, then it's a quadratic polynomial. If the degree of the polynomial is 3, then it's a cubic, so this one has degree 3, so it's a cubic. And degree 4, right here we have a degree 4 term and then a degree 1 term. Those are quartic. We typically don't talk about quartic that much, but it's good to know that there is a name for it. So our examples. The first thing we always want to do is write everything in descending order. So we want to pick the highest degree terms first. So our highest degree term is n to the 9th. And that has a minus sign in front, so we're going to put a negative sign out here. Then it goes plus 3 n to the 7th plus n to the 4th minus 4n. That's descending order for this polynomial. Then this is a polynomial. It has more than 3 terms, so we don't really have a special name for it. The constant term, there's nothing here without a variable. So the constant is actually 0 at this point. The leading coefficient, the highest degree term, is this 9 term, the n to the 9th. The number that's multiplied to the n to the 9th is -1, so the leading coefficient is -1. And the degree of that one is 9. So again, we'll write this 7x squared plus 8x cubed minus 4 in descending order. So we have 8x cubed plus 7x squared minus 4. That's a trinomial. Because it has 3 terms. The constant, this is the one without the variable, so that's -4. The leading coefficient is 8. And the degree is 3. The reason we care about these numbers, this constant tells us how, when we're graphing these, how far up and down the y-axis the whole graph moves. The leading coefficient tells us what direction it's going to be and how wide or small how wide or narrow it'll be. And the degree kind of tells us the shape of what the graph is going to be. These are all things we're going to get into in chapter 3, but it's good to know that there are reasons we're looking at this stuff. That's it for today. Talk to you tomorrow.